Hello, and welcome to the Simutech video series. My name is Tyler Coffey, and today I'm going to be discussing how to use submodeling with ANSYS version 14.5 in static structural analyses. Submodeling is a technique that uses the displacement solution of a larger, relatively coarse model as the boundary conditions for a smaller, finely meshed model. This technique is based on Saint-Venant's principle, which I will discuss in a little more detail later. In the example on the right, the top model is the coarse model, and the bottom model is the submodel. Submodel is formed by cutting a small region of interest out of the coarse model. Submodeling is a useful tool for several reasons. It can improve runtime by allowing the user to run two models with lower mesh count instead of one model with a large mesh count. Sometimes it's not practical to model small features like fillets in a large model, but the stresses in some of these regions is still of interest. Submodeling allows the user to omit these small features from the large model while still obtaining the associated stresses. Submodeling is especially useful in analyses that require repeated solves, like design studies for fillet radii or mesh convergence studies. In a design study, for example, the coarse model would only need to be solved once, and fillet radii or other small features could be changed and analyzed quickly using the submodel. Now that we've discussed what submodeling is and why it's useful, let's go through the process of submodeling in ANSYS 14.5. I've set up a model here that has the coarse model. It's already solved, so I'm going to open that up in Mechanical. You can see here it's the pulley model from the slides. It's pretty simple loading, just a fixed support on this face and a bearing load on this face. The region we're interested in is this area here. These edges here and this edge are welded and will have a fillet radius. So that's what we're interested in. We're going to be creating the submodel by cutting around this circle and cutting through this rod here. I'm going to go back to the project page and create a new static structural model for the submodel. I'm going to connect the engineering data here so that I don't have to redefine my materials. And I've already prepared the geometry for the submodel, so I'm going to import that now and open it up in Mechanical. So here's the submodel. You can see I've made a few changes. I've cut out just the section we're interested in, added fillets, and sliced up the body and design modeler to help meshing. I'm going to insert a body sizing on all of the bodies of 1.5 millimeters. Then I'm also going to create a sizing on the fillet faces, which I've created as a name selection in Design Modeler. And 1/4 millimeter. Last sizing, I want to grab this edge and the ones it's attached to, so I'm going to say extend the limits. And insert a sizing. And this one I'm going to do by number of divisions, and I want 15 per edge. And finally, I'm going to insert a multi-zone method on these 4 bodies in the middle. If I go back to the coarse model, you can see the mesh. It's a very coarse mesh for this model, so it'll be a much finer mesh in the submodel, which you can see here. So I'm going to go back to the project page and drag the solution cell of the coarse model onto the setup cell of the submodel, and this will allow us to use the displacements as boundary conditions in the submodel. I'm going to double click the setup cell. It asks if I want to read the upstream data, and I'll say yes. So now you can see I have the submodeling folder here. I'm going to right click that and say insert displacement. Now I need to select the cut boundaries. So it's these two faces, and then I'll say extend to limits. So when I right-click the imported displacement and say import load, it'll take the displacements from the course model and interpolate them onto the mesh of the submodel. Now you can see the vector plot of the displacements that are going to be applied. So now that's the only boundary condition, so it's ready to solve. And as I mentioned before, submodeling is based on Saint-Venant's principle. This principle states that replacing a load with a statically equivalent load only affects the stress distribution near the area of application. A common example of this type of exchange is modeling a distributed load applied over a small area as a point load. When analyzing a submodel, it is important to make sure that the loads in the submodel are statically equivalent to those in the course model. This is done by checking that the stresses on the cut boundaries in the course model and submodel are similar. Exactly how close the stresses need to be is up to engineering judgment, but it's important to always compare the stresses on these cut boundaries. If the stresses aren't comparable in the submodel and course model, the boundaries need to be moved further away from the stress concentrations in the submodel. Refining the mesh on the cut boundaries in the course model can also sometimes help with this problem. So now I'm going to insert a stress and scope it to this cut boundary. Right, so you can see it's about 33.6 megapascal maximum and about 18.5 megapascal minimum. And this kind of stress distribution. If I go back to the course model, I've set up a construction geometry surface on the cut plane and set up a stress result there. So here we can see it's a similar stress distribution, 35.5 megapascal maximum and about 20 megapascal minimum. So pretty close. Again, exactly how close they need to be is an engineering judgment decision. So from here, I would check the stress on the other cut boundary and make sure that's similar. And then I could post-process the stress results in the fillets and the rest of the submodel. This completes the demonstration of how to create a submodel in ANSYS Workbench version 14.5. Please visit us online at www.simutechgroup.com. Thanks for tuning in, and good luck with your modeling.